Okay, so let's continue, and this time we're going to have a look at some things called arithmetic series instead. So a series, it says here, a series is a sum of terms in a sequence. When we say a sum of terms in a sequence, really what we mean here is just the terms in the sequence are being added together. You know that that's what the word sum means. You will encounter series in many places in A-level maths and further maths. For example, there will be arithmetic series, geometric series. You've already come across binomial series before, and for my further maths students, you know that we've got Taylor series as well, which are basically sequences, but they've just got some add signs coming in between them. So, a couple of things we need to know here. We already know this. We know that the nth term of a sequence is un equals a plus n minus 1d. But we're now also going to come up with this new one, which is that the sum of the first n terms is Sn, so we're using the capital letter S here to say the sum, and the n in the corner to say how many terms we're adding up, is equal to n over 2 brackets 2a plus n minus 1d. So you can actually see some real similarities between these things that we've got here. They're nearly the same, apart from there is a 2 in front of the a, and the whole thing is being multiplied by n over 2. So we're going to prove it, but in order to prove it, I'm first of all going to have a look at doing it with some actual numbers to begin with. So there's an arithmetic sequence that we've got here, which is 2, 5, 8, 11, 14, 17, the same one that we've been using so far, and we're going to find out how much the first 5 terms add to. Well, obviously, you could just type this into your calculator, but we're going to just try and show you a method that will help us come up with a more general proof. So I'm going to do this trick where underneath I'm going to write the same series again, but I'm just going to write it in reverse order. So I have 14 plus 11 plus 8 plus 5 plus 2. And what you should notice when we write it in this reverse order is that we have this pair, this pair, this pair, this pair, and this pair. And all of those pairs seem to add up to the same thing, which is the trick that we use. So if I was going to add these two things together, as I was going to add this one and this one, I would have 2 times the sum up to 5 is equal to 1, 2, 3, 4, 5 lots of 16. So the sum up to 5 is going to be 5 over 2 multiplied by 16. The reason I've written it like this is because n is the 5 and 2 is because we're halving it because of this bit that we had here, and this 16 is going to be something to do with this thing that we've got in here. So 5 times 16, that's 50, or let's do this instead, let's do 16 divided by 2, which is 8, and times that by 5, which is 40. So these 5 numbers that we have here, they add up to 40. So we're now going to try and come up with this formula more generally. So I'm going to say that S of n is equal to a plus, and the next term in the sequence would be a plus d. Then we would have a plus 2d plus dot dot dot. At the end we would have a plus n minus 2d plus a plus, let's erase that for a second, a plus n minus 1d. We're going to do the same technique that we did before, so I'm going to rewrite the sequence out again, but this time I'm going to put it in reverse order. So we'll have a plus n minus 1d plus a plus n minus 2d plus dot 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 plus, and then these last two that I'd have here would match up with, well, this last one is going to be with an a, and this one is going to be my a plus d. So it's a little bit tricky to see the pairs this time, but one of the pairs is this here, another pair is this here, one of the pairs is this one here, and the other pair is this one that I've got here. I just didn't actually write in one of them that could have gone with this one here, so maybe it would be better actually to not even include that one here. Let's just get rid of that one and just say that we never even used it. Let's just say we just pretended it was somewhere inside this dot 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 bit that we've got. Now, there are n of these. There are n of these red loops because the sequence has got the series has got n terms in it, so there must be n pairs of it. Okay, I'm going to add them together now. So I'm going to have two lots of Sn. Let's go back to, where's my pen gone? So I know that 2Sn is going to be n lots of these pairs added together. Now you can just check for a second. If we added these together, you would have 2a plus n minus 1d, 2a plus n minus 1d. But these ones here, people sometimes find a bit harder to see how they add up to the same thing. So I have a plus d plus a plus n minus 2d. So clearly we have 2a plus d plus, here we have dn minus 2d. So that's 2a plus dn minus d, which is 2a plus n, whoops, not factorising out an n there, factorising out a d, plus d brackets n minus 1. So you do have 2a plus n minus 1d, the same as you have for all of them. So you get n lots of 2a plus n minus 1d. So the sum to n, dividing both sides by 2, is n over 2. Pen is being rather annoying. N over 2 brackets 2a plus n minus 1d. And that is the proof of generally why the sum of the first n terms is equal to this. Okay, so let's just remind ourselves what we did, because this has come up in an exam question before. Is you write the series out, you then reverse the order of the series, and when you reverse the order of the series, you notice that each pair, just like it did with the numbers, each pair adds up to the same thing. It's really easy to see it for the first one and the last one. I did it again for this second one, and actually this penultimate one. I showed you that it also adds up to 2a plus n minus 1d. And when you add both of them together, you would have double of what the sum is, and there were n pairs of that, because there are n loops of these reds here. So to find out the series for just one of them, you divide the whole thing by 2. Now this formula you need to know off by heart. There is one variation on this formula that we're going to just talk about on this next slide here as well. The alternative formula is, instead of saying that our formula was going a plus d, a plus 2d, blah blah blah, all the way up to a plus n minus 1d, instead, let's just suppose that the last term was capital L, as in L for the last term. We saw earlier that each opposite pair of terms, first and last, second and second last, added to the same total, in this case, a plus L. So here, a plus L, because the first term was 2, and the last term was 14, and they all added up to 16. So the same thing in this case as well. The first one is a, and the last one is a plus n minus 1d, and each of these pairs added up to a plus n minus 1d. All of the pairs added up to the first one plus the last one added together. So instead, you may sometimes use this formula instead, where the bit inside the brackets, which said 2a plus n minus 1d, is just going to be replaced with n over 2 a plus l. So in other words, it is the first plus the last. You multiply it by how many pairs that there would have been, and then you divide it by 2. Okay? Same as the previous idea, but we can use this if we know what the first one is and we know what the last one is. It can save us some time doing all of that substitution. Okay, so let's have a look at this. We're going to find the sum of the first 30 terms of the following arithmetic sequences. I'm going to put this down here, but this is something that you need to know. We know that Sn is equal to n over 2 brackets 2a plus n minus 1d. And this is now just going to really be a substitution. So let's pull out some of the values that we know here. We know that there are 30 terms in this sequence, in this series. I always say sequence when I mean series. So n is equal to 30. We know that a is equal to 2. And we know that d is equal to 3, because it's going up in threes. So we want to find the sum of the first 30 terms. So we're going to put 30 in the corner like this. And we know that it is equal to n over 2, which is 30 over 2, multiplied by 2a, which is 2 times 2, plus n minus 1, which is 30 minus 1, multiplied by 3. So that's 15 multiplied by 4 plus 29 times 3, which is 1,365. Okay, so that's the sum of the first 30 terms for this one. Again, for this one, we know that n is equal to 30. The first term is 100. Careful here, the common difference is actually negative 2. It's going down by 2 each time. And we want to find out the sum of the first 30 terms. So it's going to be n over 2 and then you've got 2a plus n minus 1 multiplied by the common difference, which is minus 2. So just be careful with any of your negatives and things you've got here. So that's 15 multiplied by 200, and this is 29 multiplied by minus 2. So that's minus 2 times 29. And then putting that into our calculator, that's 200 minus 2 times 29 multiplied by 15. And so you get 2,130. You could check this if you really wanted to. You could add up all of these numbers, the first 30 numbers in this sequence. Okay, this one that we've got here, a is p. Oh, didn't say what n was. N is still 30 because we want the first 30. A is p. And what's the common difference? How much are we adding on each time? Good, we're adding on p. So we're just going to say that the sum of the first 30 terms is equal to n over 2, so that's 30 over 2, brackets 2 times a, which is just 2p, plus n minus 1, let's go a bit quicker, n minus 1 multiplied by the common difference, and the common difference is p. So that's 15 multiplied by 31p, and 15 multiplied by 31 is 465. So it is 465p. Okay, now you can just start seeing how you can use some of the previous knowledge that we've got. It says find the minimum number of terms. So the number of terms is actually going to be referring to n here. Find the minimum number of terms for the sum of 4 plus 9 plus 14 to exceed 2,000. So I want the sum to n to be bigger than 2,000. So let's figure out what some of the things are that we've got here. We know that a is equal to 4, and the common difference is equal to, it's going up in 5s, and the common difference is 5. So let's move this a second so I've got a bit more space. So the sum to n would be n over 2, brackets 2a, plus n minus 1d, and I want that to be bigger than 2,000. So we get n over 2, 8 plus 5n minus 5 to be bigger than 2,000. I'm going to just get rid of this 2 here and multiply it up to the other side, and then I'm going to multiply by, let's just do this a little bit slower. So we get n brackets 3 plus 5n greater than 4,000. And then I'm going to expand this. It's going to be a quadratic, and I'll put it all on one side. So let's see what we've got here. We would have 5n squared plus 3n minus 4,000 has got to be greater than 0. So I'm going to go to my equation solver to get what the critical values are. So that's 5, 3 minus 4,000. And the critical values are that n is 27.98, or n is equal to minus 28.58, but that one's not going to be very useful for us. So the minimum number of terms for it to exceed, so this is actually saying that n has got to be greater than 27.98, so that actually means the minimum number of terms is 28. Now if you take 28 and actually just substitute it into this formula that we've got here, we should see that it's bigger than 2000. So let's just check that. So I'm going to do 28 divided by 2, and I'm going to multiply that by 8 plus 27 times 5, and it's 2002. So that is going to be the first term that is bigger, the first term that makes the sum of the series bigger than 2000, okay? So I'm just going to do one worded arithmetic series question. There are going to be many more worded series questions as we go through the rest of this unit. So we're just going to do one with a worded problem, just because I think it's useful to expose you to that now. And then you can do exercise 3B, and that's enough for us on sequences and series today. What we'll look at next lesson is geometric. Okay, so if you want to, have a go at this question after you've done exercise 3B, and pause the video and then come back and see if you've got the same answer that I do. Okay, so it says a company offers 2 salary schemes for a 10-year period, year 1 to year 10 inclusive. That just means it includes year 1 and it includes year 10. Salary in year 1 is £p, and the salary increases by £2t each year, forming an arithmetic sequence. The salary in year 1 for the second scheme is p plus £1,800, and it only increases by t each month, forming an arithmetic sequence. So this scheme, you get a smaller amount of money to begin with, but each year the amount of money that you get increases by double the amount that it does in the second scheme. And in the second scheme, you get more money in the first year, but it increases by a smaller amount each year. It says, show that the total earned under salary scheme 1 for the 10-year period is 10p plus 90t pounds. So all it wants us to do for part A of the question is literally for scheme 1 just to find out the sum of the first 10 years. So we know that n is equal to 10, we know that the starting amount of money in scheme 1 is p, and we know that the common difference is 2t. So we're just going to go straight in with the formula, so that the sum of the first 10 years is n over 2 brackets 2a plus n minus 1, which is just 9, multiplied by 2t. So that becomes 5 times 2p plus 18t, which is 10p plus 90t, as they wanted. Then it says, for the 10-year period, the total earned is the same for both salary schemes. So the total earned, it doesn't say that the amount earned in 1 year, it means the total, which should make you think of all of the years being added together. And we're going to try and find out the value of t. So let's have a look at what we're going to do. We need to find out how much is actually earned in scheme 2. So for scheme 2, again, n is 10. Apart from this time, the starting amount is p plus 1800, and the common difference is just t. So we can say that the sum of the first 10 terms is going to be n over 2, which is just 5, 2a, which is going to be this multiplied by 2, which is 2p plus 3600, plus n minus 1d, which is just 9t. So we end up with 10p plus 3,600 times 5, that's 18,000 plus 45t. And so we know that this one here and this one here are equal to each other because the total earned is the same for both salary schemes. So I'm just going to now make them equal to each other. So that is 10p plus 90t equals 10p plus 18,000 plus 45t. Luckily the 10p's cancel, and I can subtract 45t from both sides, so I get 45t is equal to 18,000, so t is equal to 18,000 divided by 45, which is £400. Then it says the value of t, for this value of t, the salary in year 10 under salary scheme 2 is 29,850. Find the value of p. So we have to now find out something different. It's now not saying the sum in year 10, it is saying the actual salary in year 10 in salary scheme 2. So this time we're actually not asking about SN, we're actually asking about U of 10. And we know that U10 is equal to A plus N minus 1 Actually, let's just write un is equal to a plus n minus 1d, and we're just going to go straight in with what u10 is, okay? So let's just erase that for a second, and let's say what u10 is going to be equal to. So we know that u10 will be the starting, which is p plus 1800, plus n minus 1, which is just going to be 9 multiplied by t, which we've just said is 400. And we know that u10 is 29,850. So 29,850 is equal to p plus 1,800 plus 3,600. So p is equal to 29,850 minus 1,800 minus 3,600, which is £24,450. Okay. Hopefully you got the same answers as me. If you didn't, maybe I've made a mistake. I don't think I have though. So you can now try some questions from exercise 3B, and that's us done on arithmetic sequences and series.